Okay, number 6. So in number 6, again, just to kind of start with a general strategy, in number 6 I have a log and a number. So ultimately I'm going to want to rewrite this as an exponent to solve it. Okay, but I've got to get rid of any numbers that are outside of the log first. So what should we get rid of in number 6? The -2. How is that -2 attached?
Multiplication.
Okay, so what are we going to do?
Divide.
We are going to divide, yes. Okay, so I'm going to divide by -2. Divide by -2. I'm just going to rewrite this over here. So I'd end up with log base 3 of 5x is equal to +2. Okay. Now, from here, how would I rewrite it as an exponent? Somebody raise your hand. How would you rewrite that as an exponent? Nuri? Equals? Yeah. So I could take this and rewrite it in exponential form as 3 to the power of 2 is equal to 5x. Okay, so it's always this number is the base and this answer to the log is the exponent. Okay, well what's 3 squared? 9. So now I have 9 equals 5x. And then what? Let's divide by 5. I think you get 1.8. That sound right? Good? Okay. I'm not going to do number 7 because number 7, there is one just like it in your notes. Okay. But I would start by adding 10 to each side, if that helps. Okay, did I hear number 10 we needed? From number 10? Okay. From number 10. Okay. When I have 2 logs equal to each other, where they're the same base, and I don't have any other random numbers floating around out there, what's the easiest thing to do with something like number 10? Cancel the logs, yeah. If I have log base 5 of this, log base 5 of this is equal to log base 5 of that, then this and that would have to be the same thing. Okay, if the 2 logs are equal, then the 2 things you're taking the log of must be equal. So I'm going to cross those out, and I end up with 4x equals x minus 3. Now, I got a lot of questions at this point yesterday. There were a lot of people who knew what to do with the logs, but then at this point they didn't know what to do. This is old stuff. What do I do first? What do you think? Okay, if I add a 3, the problem is, can I add a 3 to 4x?
No.
It could be 4x plus 3, yes. But would that get me any closer to getting x by itself? Probably not. Okay. What do you think, Garrett? Yeah, let's subtract x. What's 4x minus x? 3x. It is not 4. I see some people say 4x minus x is just 4. I see where you're getting that. You're just getting rid of the x. But remember, this is really 4x minus 1x, which is 3x. And that equals -3. And then let's just divide by 3. And we end up with x equals -1. Yep. What else would you like to see, Emily? 16? Okay. Oh yeah, 16 looks fun. And did I also hear 15? Did we need 15 and 16? Okay. So 15, I've got 3 different logs in this problem. But do I have any other numbers that are not logs? In number 15?
Yeah.
Yeah.
What?
Oh, no. I was looking at number 16.
Okay. 15. Everything in that problem is part of a log. There's not like a equals 5 in there or a plus 2 or anything like that. Everything that's in that problem is part of a log. And so, yeah, but that's inside a log, right? Log of this. Okay. What I mean is if you look down at like number 17, see how there's just a 1 in number 17? Here there's no numbers that are not part of a log. And so what I'm going to really shoot for is just like we did up here in this part 3, I'm going to shoot for combining logs until I have one log equal to another log. And then I can just cancel out the logs. Okay? So in number 15, let's talk about how to combine these two logs. That's subtraction, right? And if that's subtraction, then what do I do with the two things I'm doing the log of? If it's subtraction, I would divide. Okay, so I'm going to turn this into log base 6 of x plus 1 divided by x is equal to log base 629. Okay, this is going to be kind of a weird one, but I think you know how to do it. Okay, now what can I do now that I have log equals log?
Cancel the log.
Cancel the logs. Yep. They're the same. Yep. So good point though. They do have to be the same. So x plus 1 over x equals 29 now. Now this is kind of a weird one to solve, but you know all of the steps you need to do. What would you do first here?
You would multiply.
Okay. Multiply by x. Very good. Yeah. I would multiply by x on both sides, making this x plus 1 equals 29x. Okay, I would subtract an x. Whoops, that shouldn't be division. I was thinking ahead a step. So 1 equals 28x.
Divided by 28.
Yes. And remember, you always want to divide by the number that's in front of the x, even if it makes it weird. And I would probably, because 1 over 28 is going to be an ugly decimal, I bet. So I would probably just leave this as x equals 1 over 28.
It's not too bad.
Okay, what is it? Okay, yeah, that's not terrible, but I would take it as a decimal, but you could also just leave it as a fraction. Okay, so then do we need to do 16 as well? Is 16 another one? Okay, color here. Keep these separate. Okay, 16. So 16, again, it looks a little more complicated, but I still only have logs in the problem. I don't have any numbers that are not attached to a log. Okay? So I'm going to use the same kind of strategy as I'm going to combine whatever logs I can. I'm going to combine the logs on the left and the logs on the right and make it so that I have one log equal to another log. So thinking back to when we did all those properties, how would you combine all of that? Any thoughts? It would be log base 4 of what? Okay, 12x okay, well, we're just putting it all with one log base of 4, but you're right, it would be divided by 2. One thing we're missing. This 2, where does this 2 need to go? Nope. As an exponent on the x. Okay, so that's how you would combine all of those. And that's just going back to those properties. Remember when I was having you do all those things where we were taking logs apart and putting them back together? Okay, and then that equals log base 2 of 54. Oh, sorry, not log base 2, log base 4 of 54. From here, I would cross out my logs, and so I'm left with, I'm going to put this up here, hopefully that won't confuse you. Okay, now I'm left with 12x squared over 2 equals 54. Now before I go any further, what can I do here? Okay, I could multiply by 2. I'll do it that way. I was going to suggest that we do 12 divided by 2 and just make that a 6 to begin with, but it works this way. So 12x squared would equal 108. What would you like to do from here? Yep. Divide by 12. So x squared equals 9. And then what? square root it. Yep. So x equals, now this x was not a base of a log. Okay, it was just a number here. So we can say plus or minus 3. It could be either one of those. Okay, for our answer. Remember, when you take a square root, you get 2 answers. Okay. Now let's talk about how those ones that we just did, 15 and 16, are different than 17 and 18. Okay. Anyone have a preference? Would you like to do 17 or 18?
17.
17? Okay. What's different about these is that I have this number that is not a log. So I'm not going to be able to just make it a log equal to a log. I'm still going to combine these. How would I combine these two things? Log of 2x. Yep, 2 times x equals 1. Now what I have is a situation where I've got a log equal to a number. And that's more like, I think it was part 2 on the other side. Yeah, I think it was part 2. What did you do when you had a log equal to a number before? Yeah, we would rewrite it in exponential form, right? What would this look like in exponential form? Yeah. What would this be in exponential form? Are you confused because there's no base there? Okay, the base is 10, yeah. If there's no base there, the base is 10. So I would say 10 to the power of 1 is equal to 2x, which of course 10 to the power of 1 is just 10, right? Divide by 2, divide by 2, x equals 5. Okay. So when you've got multiple logs going on, where like 2 logs are being added together or subtracted or something like that, I would combine them and see what you're left with. If you're left with 1 log equal to another log, cancel the logs and go from there. If you're... Question? Okay, this log up here didn't have a base. All right, so that's considered a common log. Anytime you don't have a base, you consider it to be base 10. Okay, sort of like when we do square roots. We don't write that little 2 on the outside, but it's really there. Okay, so same kind of thing. If you are left with log equal to a number, I would switch to exponential form and see if you can do anything with it from there. Good? Feel a little better about these? Drew?
Number 18, this is log of 8 of 8, doesn't that cancel out?
It sort of does. That's a good point. Think about this. Log base 8 of 8. So I'm looking at just this piece by itself. What that is saying is 8 to the power of what gives you 8? 8 to the power of 8 is 1, right? Or 8 to the power of 1 would give you 8. So this right here would just be equal to 1. Now, if that were like being multiplied by something, or if it were just by itself, we could sort of say that it cancels out. But what we would end up with here, this is just one way to do it. There are other ways, but it's still being added to this over here. What I would probably do with it from here is subtract it from this 2 and make this 2 log base 8 of x equals 1. Okay. I was going to say, you could have also just made this 8 times x squared. So log base 8 of 8x squared equals 2. Okay, and then rewrite in exponential form and go from there. Okay, you should come out to the same answer. You should come out to, I believe, 1 or -1 for x. Okay. Yep. All right. So what I'm